In this video we're going to look at both the hazards and the impacts of tropical storms, so nice and brief. Tropical storms are classified as having multiple hazards, and the three main hazards that they produce are to do with the winds. We know that winds in the eye wall can be up to 150 miles per hour or greater, and these can not only cause destruction to buildings and infrastructure, vehicles, etc., but they can also cause deaths directly from flying projectiles. Rainfall is incredibly intense, can cause flooding in the first instance, and also secondary hazards such as landslides and mudslides, which can wash away homes, roads, and again cause deaths. And the rainfall can be incredibly intense, 300 millimeters or even more within a 24-hour period. And finally then we have storm surges, and these cause flooding in coastal areas. They're the most dangerous hazard of tropical revolving storms, and storm surges are caused by the rise in sea level caused by the extreme low atmospheric pressure that we get associated with tropical revolving storms, but also the incredibly strong winds blowing over the surface of the sea, causing the pile up of water, which then, as it approaches shallower waters, surges inland, causing coastal flooding. Imagine you are blowing over the surface of a hot cup of tea. How many times have you blown a little bit too hard and the tea has spilt over the side of the mug? It's the same sort of effect, just on a much larger scale. And these storm surges can be huge. The Hurricane Katrina storm surge in 2005, which caused inundation along the southern coast of the USA, was 8 meters in height. And we can see here, relating to a more recent event in the diagram, Cyclone Phelan, which hit the northeast coast of India a couple of weeks ago. We see here the kinds of hazards associated with that. Between 100 and 200 millimeters of rain, a 4 to 6 meter storm surge, and winds well over 160 kilometers per hour. Okay, so the effects. Well, hurricanes or tropical storms have caused about 1.9 million deaths over the last 200 years. So a significant number of deaths, certainly. The primary effects range from the destruction of property, trees, etc., infrastructure. Farmland can be both flooded by the rainfall and the destruction of crops, but also by storm surges. So we've got the introduction of salt water onto farmland, which can cause knock-on effects, and also the primary effects of death and injury caused by flying projectiles, collapsing buildings, and so on. Secondary effects are numerous. Not only do we have lots of standing water after flooding, which can lead to infections, mosquito-borne diseases such as malaria, we have huge long-term economic impacts. The last point there, the US suffers about $5 billion worth of damage per year, but these economic impacts do vary. Many argue that they're greater in LICs, as there is little or no insurance cover available, there's poor preparation, and buildings and infrastructure is less able to withstand hazards. However, many argue that the actual economic cost is greater in HICs, because the value of their infrastructure and the complexity of it means that the value of reconstruction and rebuilding is often much higher. So really important we distinguish between the economic impacts possibly being greater in LICs, but actually the absolute economic cost being greater in HICs. So tropical revolving storms do dissipate eventually, and dissipation is caused mainly by two things. Firstly, when a tropical revolving storm moves over land, it loses that supply of warm water needed to drive that system, provide the energy to drive the system. We can see here in the diagram tropical cyclone Phelan. As it made landfall, which was when the eye reaches the coast, as it passes over the coast and heads inland, it made landfall here at 8 AM on Saturday, the 12th of October, and at that point it was a Category 4 hurricane, and again we'll talk about categories in the next couple of slides. But we see very quickly that it dissipated within 12 hours to a Category 1 cyclone, and then again so within 24 hours it was just classified then as a tropical depression. So within 1 or 2 days, cyclones, hurricanes, typhoons dissipate as they move inland. Secondly, hurricanes or cyclones can move over cooler ocean waters, so they don't have to make landfall. They can dissipate. They move poleward over cooler ocean waters, and again this removes the supply of warm water needed to drive the system. Impacts we've discussed, but I just wanted to show you here that the impacts can spread over a very, very wide area indeed. And in fact, the rainfall is certainly a significant impact. Again, looking at cyclone Phelan's impacts, we can see here areas of rainfall spreading far inland into the interior of India. And we see this quite rapid drop-off. So we've got this area of incredibly intense rainfall, 200 to 360 millimetres on this Sunday night, so within sort of 12 hours or so, quickly dissipating as it moves inland, but nevertheless a widespread area affected by rainfall from this cyclone. Finally then, how do we measure the impacts or magnitude of tropical revolving storms? Well, we use something called the Saffir-Simpson scale. This categorises tropical storms into 5 different categories, and related to its wind speed, the size of the storm surge and the surface pressure. And we can see down here that we have our 5 categories. Category 5 being the most severe, wind speeds of 156 miles per hour or greater, surface pressure less than 920 millibars, and a storm surge of over 5.7 metres. Category 1 being the least severe. The Saffir-Simpson scale not only relates to those characteristics such as storm surge, pressure and rainfall, we can also link it to descriptive indications of damage. So here's an example of the Saffir-Simpson scale linked to damage. So we've got various damage levels relating to Category 1 minimal right down to Category 5 catastrophic. And I'll let you have a read of the descriptions there, but that's the kind of impacts that different category hurricanes can actually have.